The James Webb Space Telescope provides astronomers with an unparalleled view of the cosmos, revealing intriguing discoveries that continue to captivate the scientific community. In a recent endeavor, researchers directed the Webb telescope towards a remarkable assemblage of 5,000 relatively young galaxies. Among them, they uncovered a galaxy, the youngest till date, which unveiled an array of extraordinary cosmic phenomena, to a point that scientists are baffled as to how it is even possible. Well, things might seem a little blurry now in the cosmic time scale, but it's a win-win for science, and it's a win-win for humanity. Welcome to Lab 360, it's time to explore. The first data released from the CEERS survey features a region known as the extended growth strip and sends viewers back to a time shortly after the Big Bang. In this video, over 5,000 galaxies can be seen in gorgeous full color and 3 dimensions. The cosmic journey begins with relatively nearby galaxies located within a few billion light-years of Earth, and concludes at Maisie's galaxy, which at 13.4 billion light-years from Earth is one of the most distant galaxies ever observed by humanity, and is seen as it was just around 390 million years after the Big Bang. As such, this new Webb telescope video doesn't just represent a journey through space, but also a trip back through time, rewinding cosmic evolution back to a period when the 13.8 billion-year-old universe was under a third of its current age. The video is the result of data collected by the Cosmic Evolution Early Release Science Survey, CEERS, and explores a region of space called the Extended Growth Strip. The Extended Growth Strip is located between the constellations of Ursa Major and Boötes, and contains around 100,000 galaxies. Of particular interest to astronomers in this visualization is Maisie's galaxy, serving as an example of the kind of early galaxy that the JWST is capable of studying. Also, astronomers using the telescope have spotted a string of ancient galaxies stretching over 3 million light-years, connected by a cosmic filament dating back to the early days of the universe. This ancient filament of gas and stars may represent the oldest known thread of the cosmic web. This discovery can shed light on how the universe was formed and also the invisible strings that hold it together. It is anchored by an extremely bright celestial object with a supermassive black hole, known as a quasar, at its center. Over the past 20 years, research has uncovered the universe is built on a sort of scaffolding, a series of filaments and clumps invisible to the naked eye. In these clumps, dark matter and regular matter become very dense, creating the perfect conditions for the birth of stars and galaxies. Between these clumps and filaments are very low-density regions of the universe where there are very few galaxies and less matter. While the filament itself is invisible, it's possible to see how it brings galaxies together. Meanwhile, a quasar, a luminous supermassive black hole, is thought to be anchoring the filament. The team believes that eventually the galaxies will be pulled together into a cluster, much like the nearby Coma Galaxy cluster. The team also hopes that the discovery will shed more light on the cosmic web, but it is also very interested in how early quasars were formed in the universe's infancy. Speaking of quasars, astronomers using the James Webb Space Telescope have detected the most distant, actively feeding supermassive black hole ever observed. The black hole also happens to be one of the least massive seen in the early universe, measuring the equivalent of about 9 million suns, which is proving challenging to explain. Researchers observed the galaxy hosting this active supermassive black hole as part of the Cosmic Evolution Early Release Science Survey. Designated CEERS 1019, the galaxy is seen as it was when the 13.8 billion-year-old universe was just around 570 million years old. This is because the processes by which supermassive black holes grow, either by mergers between successively larger black holes or by greedily feasting on surrounding matter, should take longer than the 570 million years this black hole had to work with. This means that even black holes on a scale of that at the heart of the Milky Way, which has around 4.5 million times the mass of the Sun, should only be seen in the relatively close, and thus more recent universe. The black hole at the heart of CEERS 1019 is around 9 million solar masses. This may sound tremendously massive, but many supermassive black holes can grow to have billions of times the mass of our star. Yet, even at this relatively diminutive size, the existence of black holes of such masses in the early universe is still a puzzle for scientists. Looking at this distant object with this telescope is a lot like looking at data from black holes that exist in galaxies near our own, study co-author Rebecca Larson said in the statement. Scientists have long suspected that such supermassive black holes existed in the early universe, but it is only since the JWST opened its infrared eye to the cosmos in mid-2022 that definite proof has emerged. Light emissions reveal that black hole CEERS 1019 is actively feeding on matter around it. Feeding black holes like this one are surrounded by swirls of infalling gas and dust known as accretion disks. Not only does the gravitational influence of the black hole heat this matter, causing the disk to glow brightly, but powerful magnetic fields channel matter to the poles of the black hole, where it is occasionally blasted out in twin jets moving at near light speed, generating intensely bright light. Further observing the black hole's intense radiation could reveal how quickly its host galaxy is growing, and possibly shed insights on its mysterious past. A galaxy merger could be partly responsible for fueling the activity in this galaxy's black hole, and that could also lead to increased star formation. Whatever it is, scientists are looking at the data and analyzing them with precision. These data revealed by Webb has drastically changed the way we looked at the early universe. Galaxies forming only around 390 million years after the Big Bang is in itself a challenge to our model of cosmology. Of course, we can adjust the model based on the revelations made by the telescope, which we are, but there is so much more that is yet to be dug up from a plethora of information scooped up by Webb from the early universe. Scientists have also suggested that although Massey's galaxy is the youngest galaxy so far, more observations are pointing towards even younger galaxies and black holes that graced the baby universe. As such, going back to the drawing board would not only be required but will be an absolute necessity. Whatever the universe is hiding from us is only a matter of time. We will soon have the answers, or rather, know the places where we could find them. Like I said in the beginning, it's a win-win for science, it's a win-win for humanity. What do you guys have to say? Drop in your comments below, and don't forget to subscribe to Lab 360, because together, we will explore.